Okay, so we've already looked at exponential functions, and logarithms are really just the inverse of an exponential function. So in math and science, we use exponential functions quite often with bacteria growth or money growth and things like that, looking at half-lives and how things decay. We're always using something like 2 to the x, and it makes it really easy to solve for y because we can just sub in a value of x. But when we're looking at logarithms, what we're actually doing is we're considering the inverse of that. So we've got something like y equals b to the x. Well, if we were considering the inverse, we'd have x equals b to the y. Okay, now we can't really solve for this, but what we want to know is we want to know if we have some value of x, what is the exponent y that we can raise b to get. So when we're looking at this equation, we've got y equals log, and we're still looking at our base because it's our base of our logarithm or it's the base of our exponential function. But we've got, this is going to be the exponent in your exponential. Exponent of exponential. This is still our base, and this is what the answer would be of your exponential. Okay, so we're just switching around where everything is. We're taking the inverse of an exponential function. We're solving for the exponent, essentially. So if we were to rewrite these as logarithmic notation, the exponent's always going to be by itself. We've got our log. We're writing the word log, or logarithm. And our base doesn't change. So in this case, our base is 2, and we're taking the log of 8. So what this says is log base 2, and we have log 8, base 2. 2 to what exponent gives me 8 is what we're solving here. The next one, same thing. We've got our exponent. We've got our base of 5, and the answer is 25. 5 to what exponent gives me 25? So it's 5 squared. So if I were to just look at this one, I'm just going to write it down here just so it's a little easier to see. We've got S equals log R, because R is the base of the exponential function, and it's equal to T. So we've got our T. So this says R to the S would equal T. Here's the base, here's the exponent, here's the answer to the exponential. Okay, so if we're moving on, write the following in logarithmic form. So it's kind of the same thing. It's just we've got a little bit of practice here. Again, we would have 4 equals log 2, and then we've got 16. 2 to the 4 equals 16. All right, same thing. We're just getting used to doing the same thing kind of over and over and over again here. And then finally, we've got -2, and then log 3, and that's 1 over 9. Now, there's some properties that we can use that'll make things easier later on. For now, this is all we're going to look at, really. Evaluate the following logs. So what this is saying is, like, let's look at this one first. This is saying 3 to some exponent is equal to 81. So we could say something like, let y equals log 3 base 81. So now we're solving for y. Okay, and we would have this, what this really says is 3 to the y equals 81. And what we could think of in our head is, what exponent do we have to raise 3 to get 81? Well, that's 3 to the 4 is 81, so then y has to equal 4. So we've got y equals 4. Okay, same thing for the next one. We'll just let x equal log 2 to the 1 over 8. Now, if I'm looking at this one, again, I'll do it the same way. We would have 2 to the x equals 1 over 8. Really what I'm thinking of is, what value do I raise 2 to get to 8? Because when I have the 1 over that value, all it's doing is it's going to make x negative. So we're going to have x equals negative, and then 2 to the 3 would give me 1 over 8. So we would just have x is negative 3. And then finally, if I look at this last one, we've got let a equal log 10. We've got 0.01. So 10 to the 10 to the a is equal to 0.01, which is really 1 over 10 would be 0.1. 1 over 100 would be 0.01. So this is just going to be a is equal to negative 2. Okay. Last ones here are just kind of some information. If you look at your calculator, there's no, or some calculators I should say, have the option to have a different base, but most of them just say log. Now, if you look at this first one says 4 to the exponent 3 equals 64. Okay, there's a base written there. If there's no base written, like in the second one, there's no base written, it's always assumed that it's base 10. So in this one, we would have 10 to the 3 equals 1,000, which is correct. Okay, so if there's no base written, you're looking at base 10.